Well, hello there. Can anybody hear me? I can hear me. That's good enough for me. Alright, so where exactly were we? Ownership, inventory, new technology, the in-browser ID. Hey, it looks pretty good. Alright, I'm just gonna wait a moment. Oh wow. I don't have a face right now. Sure, you're all very unhappy to see that my face isn't here. You know how much you love me. That's incredible. This may be a faceless day. It may be no me. Oh! Well, it would help if I didn't cover my camera. Okay. Why do I sound like that? There's my beautiful face. I don't have a hat today. I lost my hat. I am a hatless boy. Sorry, we will start in a moment. I'm just gonna check for my hat once more. None of you want to see my disgusting hair? No, it sucks. Absolutely. Y'all are gonna have to deal with it. I'm just gonna continue stripping, you understand that? Soon enough there will be no clothes on this stream. Pop out chat. One of the quickest Alright. I'm just gonna wait for a moment. I believe I'm just gonna wait for. Sorry, talking is a difficult task. Words are a hard thing to do. You don't understand, man. You don't speak, do you? You sitting there, you've never said a word. I hate how I look on this screen, that weird blurry thing. I wonder how people do this professionally. This is still such a strange idea to me. Luckily, nobody watches me. I am a failed streamer, and that's okay with me. I can at least say that I've been a streamer, I guess? I gotta make exactly $1 to say that it was professional streaming. I'm just gonna reread this because I'm incredibly bored. Platform compatibility. The in-browser IDE does not work on touchscreens. The in-browser IDE has only been tested to work on Google Chrome 109 and Firefox 107. It might not work on older versions of Safari. The in-browser IDE uses YouTube chat doesn't work. It may work. I don't look at YouTube chat. Am I on YouTube? Probably. I try and stay the hell away from Google. Sorry for that, Silver Sorbet. Oh, hello! I have Binette. I guess that's you? Perhaps I should pop out this instead. I can see you on YouTube chat. How do I pop this out? I guess I probably can't. But it does work, see? There she is. Still you? My god, you're speaking twice! That's dangerous, having two people. I believe there's like a chat overlay, so I could technically get it on here at the very least. Or I could just go to YouTube and pop out the YouTube chat. I'm kind of curious about this. Can I do that? Why can't I do the restream thing? That's a shame. Alright. Let's pop out this chat. Ah. Oh. Yeah, that's not gonna work, is it? Sorry, I use Piped because I don't trust Google. I think that this is legitimately a crime. I don't think they like this. Ah, here we are. Okay, so we got both here now. There we go. Really, we're multi-streaming now, boys. You can't use Twitch on your laptop anymore? Doesn't let you log in. That is bullshit. I am so sorry. Can't believe they've done that to you. You know what? In solidarity, I'm gonna keep the YouTube chat much larger than the Twitch chat. Look, man, if they kick me out, if they delete me, nothing I can do. You know what? I think I deserve it. You use Libre Wolf. Good choice. That is a very good choice. That's probably why, to be entirely honest. I used it for a bit. They really did not like it. I use Forp. I don't think it's as secure, to be honest. I think that it's a bit of a strange one. Alright. Well, we have one person in here. That is a very good thing to see. I said I would wait 5 minutes before starting this quiz. I'm glad you're the only one in here, because this is going to be embarrassing. I don't know what we were talking about beforehand. If you tried to compile this function, which of the following best describes the compiler error you would get? We have make separator, taking in a reference string, outputting a reference string. If user string is nothing, there's owncast you can use to stream, but I don't know how it works really. I've never heard of owncast. I'm using a restream right now. Restream allows you to do both. It also has a chat for both, but it doesn't allow you to pop it out. I suppose I could just build my own like iframe type deal. Free and open source live streaming. Okay, I'm going to switch to this if it allows me to do both. Thank you for showing me this. This is like really good. I think I can put a heart in chat. I'm gonna put a heart in chat. I really appreciate that. Thank you for this. I'm keeping this. This is coming in. Hopefully it's written in Rust. Who knows? I'm gonna get this. There's a git pop. Let's check this out just quickly. Give some time for other people to come in. Owncast. Built-in TypeScript, of course. That's just the UI, though. Unless it's a Node app. Wow, that's some really good UI here. Thank you. I can really read all of it. Ah, we got 40% Go. That's probably the service. TypeScript, a little bit of JavaScript. I don't know what MDX is, but you know. Seems like a decent stack. Glad to see it. I am going to check that out. Now, where were we? We are going to stop procrastinating. Again, thank you for that. If user string is empty, let default equal an equal dot repeated 10 times. Then we're returning a reference to default, which would be a reference string. Else we are return. I have no idea what the issue is here. This goes to show how little I've been paying attention. Oh wow. What does this do? Creates a new string by repeating a string n times. I don't see the reason for this. This function will panic if the capacity would overflow. The capacity. But huge equals... Oh, okay, yeah. So the reason why that panics is because it doesn't have enough space. Alright. The default is 10 equals. Passing back the original user string. The function make separator cannot return two different references. That is correct, because it doesn't know the ownership of it. It doesn't know which one it will output. Maybe not? I think that is the issue, because it doesn't understand which one it would output. It can't understand ownership throughout the entire thing. Lario? What is a Lario? You didn't miss anything, honestly. We're just going through this quiz. This is what we stopped on last time, and we're going to it now. It's a lake in Como. I love that lake. I'd tab out to it too if I were you. But yeah, so we have this function, which either returns default, which is just 10 equals cents, or a user string. And we are wondering why it would error out. If I compile this function, which best describes the error that I would receive? Cannot return reference to local variable default. That makes more sense. How can we return reference? Something that isn't there? But I believe that reference string is simply a type of string. User string does not live long enough, or function make separator cannot return a reference of type string. Yes, it can. I think it's either these two. I believe that this is the first error that it would have, but even if it could, I believe this would be the error that we'd have separately. So I'm just going to say that the issue here is that it cannot return a reference to a variable that is stored in the stack, because it would delete itself after the frame. No, I don't think strings do that. I think strings are always in the we'll just say this and go forward. We got 6 of these things. Yeah, I picked the other one, so if I'm wrong, I can still say I'm correct. Alright, question 2. We have normally if you try and compile this function, it returns this error. Assume that the compiler did not reject this function, which, if any of the following programs would 1. Pass the compiler, and 2. Possibly cause undefined behavior if executed. Check each program that satisfies both criteria, or check none of these programs if none are satisfied. Right, okay. The error originally is, well, let's read this. Make separator, user string, yep. Here we have user string equals correct. Let default repeat 10, else. Oh, this is the same thing. This is the same thing. Okay, this is... The error would be, cannot return reference to local variable default. Oh my god, it's literally just telling us right here what it was. You were right, Bennett. Why would they do... That's very funny. I am very happy they did that. That's hilarious. So the issue is, cannot return reference to local variable default. Okay. I still think the other one was an issue with it too, but that's the first one it gets. Right, so what of these... Right, so we have let n s equal make separator blank. That will which, if any of the following programs with 1. Pass a compiler, and 2. Possibly cause undefined behavior if executed. That would cause undefined behavior because it would return a reference to something that's deleted that would be use after free. I'm assuming the answer is probably also in the next question on this. It's just going to keep going on, man. Let s equals make separator blank. That does not have a use after free at all. This does. That's just it. It's just going to delete it. Secondarily, we have make separator hello world, which will return an output which is used. Hello world returns hello world. That's it. I don't see any issue. So that's fine. That's definitely not. That I think is. This one, I believe, will work perfectly fine. Because it'll just else return string hello world, and it'll just print hello world. So that's going to cause us the issue. I think that's all. Question 3. Make a string to Yep, this is the same question again. Of the following fixes, highlighted in yellow, which fix best satisfies these 3 criteria? 1. The fixed function passes the Rust compiler. 2. The fixed function preserves the intention of the original code. And 3. The fixed function does not introduce unnecessary inefficiencies. Okay. We have this. Make separator as a string, takes in a string, returns a string. If user string is nothing, output default. It's passing. I don't think that would pass because you can't. String doesn't. Maybe that will pass. Else user string. Okay, this one is just takes in a reference to a string, passes back a string. I think that this makes the most sense. This one just either A passes this back to a string. I guess that's the inefficiency it's talking about. And thirdly, we have let default equal this. We are taking in a user string and we are passing out a reference string. If user string equals let default. This is the original. I think that this is the original. No, it isn't the original. We have just added in a reference here. So we make a reference to the reference string. Apparently that doesn't do anything. That's also broken. Here I think that this is the best because it takes in a user string. Sorry, it takes in a string, passes out a string. You think the second one works? I know it works. Yeah, this does work. Takes in a reference to a string, while also passing out a string, but the inefficiency. Both of these will work. I think both of these will pass the compiler, but we also need to preserve the intention of the original code and does not introduce unnecessary inefficiencies. Passing this to a string may be an inefficiency. I don't know what make separator is supposed to do. To be clear. Both of these work. It's just, which one do you think is inefficient? I think that this adds in an inefficiency because of the to string, whereas this simply takes in a string, passes out a string. Will either pass out a string of equal signs if nothing, or B, pass out the original user string. I think this has the least amount of inefficiencies. You think the first one works because in the original one it was like string equals make separated string? Yeah. I do think that the first one works. I think the first one is the correct answer, personally. I don't think there's ownership here. I don't think ownership is the issue here. It's not borrowed. No ownership is returned. No ownership is brought in or returned. It's copying values. No, it's not. I'm wrong. Yeah, I think you're right. Ownership would be returned if you use a string. No, we're not borrowing. We're not borrowing at all. Here would be borrowing. Here is where we're borrowing a reference to a string, or reference string. Which would be a, God, what is it called? There's a term for this. A string, there's a term for this. What is it called? Well, that's not the thing. What is it called? It's like a string slice. This is a string slice. Okay, this is really showing how little I've actually brought in. Can't wait to start building some stuff so I can. Let's just go through this. I believe that the first one makes the second one may make more sense because it's taking this into a. This is taking a slice and returning a string. I think that's the best without any inefficiencies. Well, there is an inefficiency here, so perhaps it's the first. Let's go with the first. Sorry about that. Right, so question 4. We have get or default, which takes in an option of type string, returning a string. If arg is none, we return a new string. I guess dot is none is something on an option that allows for, yeah. Let s equal arg.unwrap, which just takes apart the string. Leave that brings out the sum value, and it returns the clone version of s. Try to compile this function. Which of the following best describes the compiler error you would get? Arg does not live long enough. Cannot call arg.isNone without dereferencing arg. I think that's true. Cannot move out of arg in arg.unwrap. No. Or cannot return s.clone, which does not live long enough. We haven't talked about lifetimes at all, I don't think. I think that this is the issue, because we have a reference to an option, which we are attempting to call isNone on. We are not dereferencing arg. Otherwise, the only thing I could see being an issue would be cannot move arg out of arg.unwrap. Wait, yeah, because this isn't dereferencing either. Can you... Because this function may panic, it is generally discouraged. Instead, prefer to use pattern matching and handle the none case explicitly or unwrap default. Panics if the value is none. It does not state that it dereferences anything anywhere. Either of these could be a failure. I like this LSP type deal. It's got a bunch of information in it that I'm gonna say cannot call arg.isNone without dereferencing arg. I think that might be the issue. Yeah, I'm gonna get a lot of these wrong, man. Assume that the compiler did not reject this function. Which of any of the following programs would pass the compiler, and 2, possibly cause undefined behavior if executed? Check each program that satisfies both criteria, or check none of these programs if none would satisfy. Okay, let's read through this. We have get or default, which is the same thing that we had read before. Oh, the cannot move out of arg, which is behind a shared reference. It's done it again. Okay, I was wrong. I was wrong on that. It's done it again. Wow, they really just gotta put this in your face like, here, you're an idiot. Look at this. This is the answer. My God. That's hilarious, though. I love that. Right, okay, so if this did work, and the real issue here is cannot move out of dereference arg, which is behind a shared reference. What would cause what would 1 pass the compiler and 2 cause undefined behavior if executed? We have let option equals some string from Rust, get or default, which passes in a reference to opt. So the word Rust goes into get or default. This is not none, thus it tries to unwrap. It hits this, which could cause some issue. Cannot move out of behind a shared reference. I'll admit I don't really understand what a shared reference means. Borrow the type's contents, so we are not borrowing it. Thus ownership is consumed here. Thus, I believe this will cause an issue because it is going to delete, and this is a use after free. I could be wrong. Consider calling .asref or asmute to borrow the type's content. Move occurs because the reference arg has type option string, which does not implement the copy tree. I believe that this will fail because ownership will be consumed, it is not borrowed, it will be deleted. Secondarily, we have some string Rust, opt. Wait, what's the difference? Oh, we have opt being. We have the returned value here of s.clone. What will this do? Returns a copy of the value. I think that's fine, actually. I think that one's fine, actually, because this is a value. It does consume and delete ownership of opt. Oh, maybe you were correct about it being is none, because maybe ownership was taken at is none, so it couldn't be used for unwrap. That's possible, but the error it's punishing out is this. That is the error. We were trying to get what the compiler would say. That could be why it's like that. So I do think that this is going to fail out. I think this is going to be... Sorry, this is not going to fail out. Because this consumes ownership, and opt is dead. However, opt is not used, and it is not an issue to have something that's dead and not used. S, however, is used, but S is the returned value, which is a cloned value passing back by value. I think that's perfectly fine. Let opt equals sum, and then we just call it. If we just call it, and this get or default works fine, I see no issue. I see no issue. Undefined behavior. Yeah, I don't think that this has an issue if we're just calling the function. Unless I was correct about arg is none not being able to be utilized. But if it was not able to be utilized, if I was correct with question 4, then we would see the error here and not here. So that must be fine, and thus only the first one is at issue. Question 6 of 6. Of the following fixes, now, scrolling, highlighted in yellow, which fix best satisfies these 3 criteria? Must pass the compiler, must preserve the intention of the original code, and must not introduce unnecessary inefficiencies. Alright, we have the thing we've been looking at for a little bit here. We have get or default, option string, outputting string. Right, so we bring in just a regular option string instead of a reference to an option string, and thus ownership is consumed. We are not borrowing, we are consuming ownership of this option string. If there's no we just return string new and we clone. You like the second one? You do it like this. Right, so we do not consume ownership, we borrow an option string, returning a string. We match against it with, yeah, of course we would. Why wouldn't? Why are we passing in an option if we're not using it like an option? Yeah, of course you would do that. And I see no issue with this. If it's none, we return a string new. That's fine. If it's some, with S, clone S and output it. That looks so nice. Versus this one, which takes in an option of type reference string, or a string slice, and then outputs to string. Yeah, like, why wouldn't you use match on an option? It looks so nice. It's a pretty thing. I'm not reading the rest because that's pretty and I like it. And if that's not the answer, I'm going to be upset. Oh no, I got 2 out of 6 correct. Incorrect. Function make separator cannot return to different references. Yeah, we looked over that. You were right, Bennett. You were entirely correct. Right. This one we got correct. That is the only issue. This one, we got incorrect. As stated before. No, not as stated before. That's just incorrect. We'll have to see why. This one is incorrect. As stated before. The correct one was the other one, as it states right here. This one is incorrect, and we'll learn why soon. And this one's correct, and it's pretty, and I like pretty. Alright, let's read why I'm an idiot. Correct answer is, cannot return reference to a local variable default. Yep, makes sense. Secondarily, the correct answer is... okay. Yeah. This is fine, and this was not an inefficiency created. We bring in a string slice, return a string, and convert to a string from the string slice inside the code in order to pass back a value without consuming ownership. There is no valid way to return a pointer to a stack allocated variable. The simplest solution is therefore to change the return type to string and copy the input user_string into an owned string. However, requiring user string to be a string would reduce the flexibility of the API. For example, caller would not be able to call make separator on a substring of a bigger string. It would also require caller to heap allocate strings. Therefore, it could not use a string literal with make separator. We had discussed this before. Yeah, always use string slices if possible. Most idiomatic solution is uses a constructor you haven't seen yet. How? I like cows. The clone on right smart pointer would enable this function to return either an own string or a string reference without a type error. Okay. We should look into this later. Question 4. We got this wrong. Yeah, cannot move out of arg not unwrap. The function option unwrap expects self, meaning it expects ownership of arg. Okay. However, arg is an immutable reference to an option, so it cannot provide ownership of the option. Therefore, the compiler complains we cannot move out of arg via unwrap. I'm never going to get this, to be honest. I'm just going to see the compiler error and fix it from that point forward, until eventually it bashes itself in my head. I got this one wrong. Okay. This one does create an error. Recreate an error. Ooh, okay. All of these programs violate memory safety due to a double free. Yeah, because if this consumes ownership and deletes opt, then opt will be deleted at the end. I see. So, yeah, I'm not going to get that. That's never going to be something that I understand or remember to check. Double frees in this way, due to them not being explicit, are always going to mess with me. So opt will be deleted in two separate contexts. It will A. always be deleted in get or default, and B. always be deleted in any piece of function that utilizes it. That is the issue. Yeah, let's read this entirely. All of the program's file memory safety because of a double free if arged on a ramp were permitted, then ownership of the string from Rust would be assumed by S after get or default returns. Now the string would be freed. However, opt also believes it owns the string. So the string would be freed a second time on behalf of opt. Okay. All these following fixes, highlighted in yellow, which fix best satisfies these three criteria? And we got this one correct. The combination of is not and unwrap here is a Rust anti-pattern. Since a match combines the two functionalities and automatically deals with pushing the reference option into the interior to produce a reference string. Therefore, the match solution is the most idiomatic and passes the compiler without changing the intended type signature of the function. The solution? Changing add option to option is not desirable because it requires the caller to provide ownership of their options, which is a far more restrictive API. That's good. I don't know why opt still thinks it owns the string. Sounds funny to me. That is kind of funny. I like that. Look, man, those in the BDSM community probably love this language. Here, we're on to the new one. Managing growing projects with packages, crates, and modules. This is quite a long one. We're going to be here for a while. We're going to be here for a few sessions. It looks like it's only you, Bennett. Or Silver Sorbet. I don't know which one you prefer me call you. As you write large programs, organizing your code will become increasingly important by grouping related functionality and separating code with distinct features. You'll clarify where to find code that implements a particular feature, where to go change how a feature works. The programs we've written so far have been in one module, one file. As the project grows, you should organize code. Oh no! I am terrified. By splitting it into multiple modules, and then multiple files. A package that contains multiple binary crates, optionally one library crate. Sorry, that was really terribly worded. A package can contain multiple binary crates and optionally one library crate. There are no libraries in Rust, that's a lie. As a package grows, you can extract parts into separate crates that become external dependencies. This chapter covers all these techniques. For very large projects comprising a set of interrelated packages that evolve together, Cargo provides workspaces, which we'll cover in Cargo Workspaces, Chapter 14. You're saying that this is where you got stuck? Hopefully we can help each other out of it. We'll also discuss encapsulating implementation details, which lets you reuse code at a higher level. Once you've implemented an operation, other code can call your code via its public interface without having to know how the implementation works. The way you write code defines which parts are public for other code to use and which parts are private implementation details that you reserve the right to change. This is another way to limit the amount of detail you have to keep in your head. A related concept is scope. The nested context in which code is written has a set of names that are defined as in scope. When reading, writing, and compiling code, programmers and compilers need to know whether a particular name at a particular spot refers to a variable, function, struct, enum, module, constraint, or other item, and what that item means. Create scopes, and change which names are in or out of scope. Can't have two items, same name, in the same scope. Tools are available to resolve name conflict. I believe in us. Full faith. Rust has a number of features that allow you to manage your code's organization, including which details are exposed, which details are private, and what names are in each scope in your program. These features, sometimes collectively referred to as the module system, include packages, a cargo feature that lets you build, test, and share crates, a tree of modules that produces a library or executable, modules, and views let you control the organization, scope, privacy of paths, way of naming an item, such as struct, function, or module. In this chapter, we'll cover all of these features, discuss how they interact, and explain how to use them to manage scope. By the end, you should have a solid understanding of the module system and be able to work with scopes like a pro. I doubt it. Packages and crates. The first part of this module system we'll cover are packages and crates. A crate is the smallest amount of code that the Rust compiler considers at a time. Even if you run Rust-C rather than cargo and pass a single source code file, as we did all the way back in writing and running a Rust program sector in Chapter 1, the compiler considers that file to be a crate. Crates can contain modules, and the modules may be defined in other files that get compiled with the crate, and we'll see in the coming section, A crate can come in one of two forms, a binary crate or a library crate. Binary crates are programs you can compile to an executable that you can run, such as a command line program or a server. Each must have a function called main that defines what happens when the executable runs. All the crates we've created so far have been binary crates. Library crates, however, don't have a main function. They don't compile to an executable. Instead, they define functionality intended to be shared with multiple projects. For example, the rand crate we used in Chapter 2 provides functionality that generates random numbers. Most of the time, when Rustaceans say crate, they mean library crate. They use crate interchangeably with the general programming concept of a library. Libraries can be compiled while still having different sections. Rust cannot. This is wild to me and why Rust takes so long to build. The crate root is a source file that the Rust compiler starts from and makes up the root module of your crate. We'll explain modules in depth in the Defining Modules to Control Scope and Privacy section. A package is a bundle of one or more crates that provides a set of functionality. A package crate contains a cargo.toml file that describes how to build those crates. Cargo is actually a package that contains a binary crate for the command line tool you've been using to build your code. Cargo crate. The cargo package also contains a library crate that the binary crate depends on. Other projects can depend on the cargo library crate to use the same logic the cargo command line tool uses. The package can contain as many binary crates as you like, but at most only one library crate. Why? A package must contain at least one crate, whether that's a library or a binary crate. Yeah, of course. Gotta have some code. Let's walk through what happens when we create a package. First, let's cargo new. Okay. I don't know why I'm doing that. Day 8. Right. We're creating cargo new day 8. We're seeding into day 8. ls. Here is what it is. ls source. That's main.rs. After we run cargo new, we use ls to see what's in the crate. In the projects directory, there's a cargo.toml giving us a package. There's also a source directory that contains main.rs. And cargo.toml in your text editor. And open it and note that there's no mention of source/main.rs. Cargo follows a convention that source.main.rs. That is the crate root of a binary crate with the same name as the package. Likewise, Cargo knows that if the package directory contains source/lib.rs, package contains a library crate with the same name as the package, and source/lib.rs is this crate root. Cargo passes the crate root files to RusC, build the library or binary. Here, we have a package that only contains source/main.rs, meaning it only contains a library crate named my-project, or here, day 8. If a package contains source/main.rs and source/lib.rs, it has two creates, a library and a binary, both with the same name as the package. A package can have multiple binary crates by placing files in the source/bin directory. File will be a separate binary crate. Okay, let's start this. Which is the correct order, where A over B means A contains B. Crate contains a package. Crate contains package, contains module. Nope. Package contains crate. What? Okay. Maybe I didn't understand the word I just put. A package contains a crate, which contains modules. I believe that's correct. Sure. Imagine you see a Rust package foobar with the following files. How many crates does this package contain? Write your answer as a digit. Alright, so we got cargo.toml, build.rs, we have main.rs, util.rs, under source, and lib.rs, we have one crate for main.rs, another crate for lib.rs, and a third crate, which is a binary crate. I believe that is 3. I believe util.rs is not in fact a crate in and of itself. Yep, I got that all correct. Context. Package is a top-level organizational unit containing crates. A crate contains modules. So a package is an entire project. A crate is a section of that project. And a module is a small bit of code within a section. Here we see 3. Main.rs produces a binary crate. Lib.rs produces a library crate, and anything inside of bin produces a binary crate. Util.rs will presumably be used as a module within one of these crates. Or multiple, I guess. I don't see why you couldn't use it in multiple. Perhaps they limit that for who knows what reason. But it is not a special file name recognized by Rust, so it would not be its own crate. Build.rs is a build script. Good to hear. Defining modules to control scope and privacy. In this section, we'll talk about modules and other parts of the module system, namely paths that allow you to name items, the use keyword that brings a path into scope, and the pub keyword that makes items public. We'll also discuss the as keyword, external packages, and the glob operator. Oh, glob operator. Yeah, okay. First, we're going to start with a list of rules. I'll try to run cargo for the CLI.ff thing. Alright, sure. I should have done that. I forgot to do that. Sorry about that. First, we're going to start with a list of rules for easy reference when you're organizing your code in the future. You should just be able to do cargo new CLI-ff and then pick all the files inside of CLI.ff and then copy paste them into the base and delete the new CLI.ff folder. First, we're going to start with rules for easy reference when you're organizing your code in the future. Then we'll explain each of the rules in detail, if that's what you're trying to do. Of course, if you're not comfortable, no worries. Good stuff, I'm glad. Hopefully it works out. Try and put a hello world in there if it isn't already put in there. I think she is. Yeah. Try running it at the end. If she works, she works. Here we provide a quick reference on how modules, path, the use keyword, and hub keywords work in the compiler. How most developers organize their code. We're going through examples of each of these rules throughout this chapter, but this is a great place to refer to as a reminder of how modules work. Start from the crate root. When compiling a crate, the compiler first looks into the crate root file, usually lib.rs for library crate or main.rs for binary crate for code to compile. Declaring modules. In the crate root file, you can declare new modules. Say you declare a garden module with mod garden. Alright, the compiler will look for the module's code in these places. Inline within curly braces that replace the semicolon following mod garden. Okay. In the source/garden.rs file, that would be that would be a module, or within source garden mod.rs. Okay, declaring submodules in any file other than the crate root. So this would be allowing us to use multiple different files within garden/mod.rs to organize our project better. Otherwise, we would just have one file, and I think this would make the most sense if it is just one file. Declaring submodules. In any file other than the crate root, you can declare submodules. For example, you might declare mod vegetables in source/gardens.rs. The compiler will look for the submodule's code within the directory named for the parent modules in these places. In line, as before, inside of the garden folder, called vegetables.rs, or separately, inside of the garden folder, inside of a folder called vegetables, inside a file called mod.rs. Okay, paths to code a module. Once a module is part of your crate, you can refer to code in that module from anywhere else in that same crate, as long as the privacy rules allow, using the path to the code. For example, an asparagus type in a garden vegetables module will be found at crate garden vegetables asparagus. This is the full namespace. Private versus public. Code within a module is private from its parent's module by default. To make a module public, declare it with pub mod instead of mod. That's good. I'm glad that it's that it's private by default. We shouldn't be having a bunch of stuff just be public if not necessary. This will cause more errors as you're coding, but it'll cause less errors as you're not coding. On the user space. The use keyword. Within a scope, the use keyword creates shortcuts to items to reduce repetition of long paths. This is using namespace in any other language. In any scope that can refer to create garden vegetable asparagus, you can create a shortcut with use create garden vegetable asparagus. From then on, you only need to write asparagus to make use of that type in the scope. Oh, okay, yeah. Yeah, so you could also use create garden vegetables, then use vegetables, asparagus later on in your code if you have a bunch of different vegetables. This is just using namespace. Here we create a binary crate named backyard to illustrate these rules. Crates directory, also named backyard, contains these files and directories. We have backyard with cargo.log, cargo.toml. In source, we have garden with vegetables.rs. We also have garden.rs and main.rs. Main.rs is the beginning of our crate, which can bring in garden. And within the garden folder, we have vegetables. I don't like this structure. You should put it in mod.rs here. The crate root file, in this case, is source/main.rs, and it contains source/main.rs. Use crate garden vegetables asparagus. We now have access to asparagus. pub mod garden, we have garden, which is a public module. Function main, let plant equal asparagus with square brackets for no code. Print line, I'm growing, and plant. Will that just output asparagus? The pub mod garden line tells the compiler to include the code it finds within source / garden.rs, which is source / garden.rs has public mod vegetable. Here, pub mod vegetables means that code in source garden vegetables.rs is included too. That code is derive debug pub struct asparagus. Alright, so asparagus is a struct with nothing in it. And we also have the derive debug characteristic here. So this, with pretty printing, will output the name of plant. That's about it. Now let's get into the details of these rules and demonstrate them in action. Grouping related code in modules. Modules let us organize code within a crate for readability and easy reuse. Modules also allow us to control the privacy of items, because code within a module is private by default. Private items are internal implementation details not available for outside use. We can choose to make modules and the items within them public, which exposes them to allow external code to use and depend on them. As an example, let's write a library crate that provides the functionality of a restaurant. Define the signatures of functions, but leave their bodies empty to concentrate on the organization of the code. We'll define the signatures of functions, but leave their bodies empty to concentrate on the organization of the code rather than the implementation of a restaurant. In the restaurant industry, some parts of the restaurant are referred to as front of house, and others as back of house. Front of house is where customers are. This encompasses where the hosts seat customers, servers take orders and payment, and bartenders make drinks. Back of house is where the chefs and cook work in the kitchen. Dishwashers clean up, and managers do administrative work. To structure our crate in this way, we can organize its functions into nested modules. Create a new library named restaurant by running cargo new restaurant --lib. Alright, I don't know why it asked us to do this one. Let's just delete day 8 because that was useless. Cargo new. We are going to call it restaurant --lib. Okay. Oh, it added in a little bit more information to this. DFG test, mod tests. Oh, it brings in the tests infrastructure. I don't know why it does that in just here. Is this really the best idea? Alright, we'll see. Then enter the code in listing 7 into source/lib to define some modules and function signatures. Here's the front of house section in file source lib rs. Let's cancel all this out. Let's get to the bottom of this. Mod front of house. Mod hosting. Function add to waitlist. An empty function. Function seat at table. Let's just call it seat. No. Which is an empty function. This is the end of that. We have another mod called serving, which takes in a function, which has a function called take order. I'm just going to copy this because the rest is kind of meaningless. Like, I learned nothing by typing in that code. By the rest, I mean the entire thing, honestly. That was not a useful use of my time. Never use. Good. Run a fast module containing other modules. Alright, we define a module with a mod keyword followed by the name of the module, in this case, front of house. The body of the module then goes inside curly braces, inside modules. You can place other modules, as in this case, with the modules hosting and serving. Modules can also hold definitions for other items, such as structs, enums, constraints, traits, and as in list 7.1, functions. Right, so we can just hold a bunch of stuff. By using modules, we can group related definitions together and name why they're related. Programmers use this code, navigate the code based on groups rather than having to read through all the definitions, making it easier to find definitions relevant to them. Right, yeah, you can just go to implementations on any of these or go to definition. Well, this would be the definition. You have to go to implementation to see it actually see the code, but this is the separate grouping. I can understand that. That's good. So when entering into a library, you should always look for the definition of the modules in order to get a structure of how the code is built. Good. Programmers adding new functionality to this code would know where to place the code to keep the program organized. That is very important. That is very important. New devs on a project can mess up your program quite easily by just putting it anywhere. And you, being a new dev on a program, will probably mess up and put code where it ain't supposed to be. Earlier we mentioned that source main.rs and lib.rs are called crate roots. The reason for the name is that the constraints of either of these two files form a module named crate, at the root of the crate module structure, known as the module tree. This shows the module tree structure for listing 7-1. We have crate, front of house, the hosting, two functions, serving, and the through function. This tree shows how some of the modules are nested inside one another. For example, hosting nests inside front of house. The tree also shows that some modules are siblings to each other, meaning they're defined in the same module. Hosting and serving are siblings defined within front of house. Module A is contained inside module B. We say that module A is the child of module B, and that module B is the parent of module A. Notice that the entire module tree is rooted under the implicit module named crate. The module tree might remind you of the file system directory tree on your computer. This is a very apt comparison. Just like directories in a file system, you use modules to organize your code. Just like files in a directory, you need a way to find your modules. I just dump everything into main. Hell yeah? Silver Sword Bang at it again? Did you, out of curiosity, did you push it up? Wow. I tried 4 times at this. What? Oh yeah. Hey, here we go. I got it on my machine. Thank you for that. By the way, when the folder already has stuff in it, it's cargoes and init path. But yeah, I pushed it. Okay, yeah, sure. Looks like that worked out great. I'm very happy you did that, and apologies for not doing that myself. Of course, it's a bit easier since this is Rust. It doesn't have that much in it. But still, I do appreciate you helping out there. Okay. Now let's do this quiz. Which of the following is not a benefit of using a module? Modules group related code so programs can easily work. Yep. That is a benefit. Modules provide a scope to avoid naming conflicts across parts of the code base. Don't think that's true. Modules boost the runtime performance of interdependent code within the same module. That is untrue entirely. Modules encapsulate implementation details that shouldn't be used by external clients. That is correct. I guess this is also correct. Oh, yeah, I guess that absolutely is correct. It does avoid scope-based problems. The issue here, the thing that is not a benefit, is performance of interdependent code. Okay. Modules have no effect on runtime. They're purely for compiler time organization. Just a moment, I'm going to take a second to take a sip of tea. Look, the modules actually do, but only if they're read with flames. If they're not, it doesn't actually go faster. Fast for referencing has to refer has for referring to an item in the module tree. Show Rust where to find an item in the module tree, we use a path in the same way we use a path when navigating a file system. To call a function, we need to know its path. Path can take two forms: an absolute path, full path starting from the crate root, for code from an external crate. The absolute path begins with the crate name. For code from the current crate, it starts with the literal crate. So crate is the this of Rust, if this actually meant something. A relative path starts from the current module and uses self, super, or an identifier in the current module. I don't know what that means totally. I mean, I know that starting from the self, if you have like 5 files down, it's at the 5th file, and if we want to go, we could go to the 6th, 7th file, or back to a 5th and 6th alternative file. But I don't know what self, super, or an identifier in the current module means. Both absolute and relative paths are followed by one or more identifiers separated by double colons. Okay. Oh, okay, so self would be like the actual file. Oh, I see now. So that would be self, colon, and then from that point forward, for this current file, downward, what would super be, however? Returning to listen 7.1, say we want to call the add to waitlist function. This is the same as asking, what's the path to add to waitlist function? Listing 7.3 contains listing 7.1 in some of the modules and functions removed. What? With some of the modules and functions removed. Okay. We'll show 2 ways to call add to waitlist function from a new function eat at restaurant defined in the crate root. These paths are correct, but there's another problem remaining that will prevent this example from compiling as is. We'll explain why in a bit. That restaurant function is part of our library crate's public API. So we mark it with the pub and the exposing paths with the pub keyword section. We go into more details about pub. Right. In source/lib, we have front of house, mod hosting. We have this in there. We also have the letter C. We don't need the letter C. We also have a new public function called eat at restaurant. I hate underscores. Which has an absolute path. Great. Call front. Well, I'm just gonna listen, because that's quite self-explanatory. I am gonna keep it all here in case it's actually useful. Why haven't you copied? Fantastic. I could have written it all out from that point, but you know. So you have the crate, which is the root, front of house, which is here, this module, hosting, which is here, and we have add to waitlist, which is here. Then we have a relative path. Here's a little bit more information. We have, what's wrong? What is wrong with that? Huh. Function add to waitlist is not publicly re-exported. Yeah, okay, since that's not public, how can public function use it? What? I guess we might see later. What's going on here? Functions is a part of our current API, so we'll mark it with the pub keyword in the exposing as with the pub keyword section. We'll go into more detail about pub. First time we call add to waitlist function in eat at restaurant. Hello. Who are we? Oh, I play too much Rust. What am I doing? We are currently learning the Rust programming language. I'm assuming you're not from Lemmy, the alternative Reddit-like platform, and you're just looking for Rust gameplay. I'm sorry. You will not find Rust gameplay here. This is a programming language called Rust. They're also called Crablang, as you can see this little guy up here. We're just learning how to write it so that we can make programs. Good to see you though. Alright. The first time we call the add to waitlist function in eat at restaurant, we use an absolute path. The add to waitlist function is defined in the same crate as eat at restaurant, which means we can use the crate keyword to start an absolute path. We then include each of the successive modules until we make our way to add to waitlist. You can imagine a file system with the same structure we'd specify: path / front of house / hosting / add to waitlist. Run the add to waitlist program using the crate name to start from the crate root is like using / to start from the file system root in your shell. Or on Windows, that would be C::/ or C/:, whatever it is. I don't care. The second time we call add to waitlist in eat at restaurant, we use a relative path. Path starts with front of house, name of the module defined at the same level of the module tree as eat at restaurant. Here, the file system equivalent would be using the path front of house, hosting, add to waitlist. Starting with a module name means that the path is relative. Okay, so the difference here is this is like using it from the root and then going up, versus here, which is like, hey, where we exist right now, forward. Choosing whether to use a relative or absolute path. Sorry, just a moment. This may be a bit difficult here. Choosing whether to use a relative or absolute path is a decision you'll make based on your project. It depends on whether you're more likely to move item definition code separately or together with the code that uses the item. For example, if we move front of house module, the front of house module, and the eat at restaurant function into a module named customer experience, we'd need to update the absolute path to add to waitlist. But the relative path would still be valid. However, if we move the eat at restaurant function separately into a module named dining, the absolute path of add to waitlist call would stay the same. The relative path would need to be updated. Our preference in general is to specify absolute paths because it is more likely we'll want to move code definitions and item calls independently of each other. Let's try to compile listing 5 or 7-3 and find out why it won't compile yet. The error we get is shown in listing 7. Module hosting is private. Yep. That is what it's complaining about here. Let's just try it. Well, what? Cargo build? Oh, I see. Yep. You do? Well, that's the issue. Yep, here is the error. Function add to waitlist is not publicly re-exported. The same error we see here. Let's see why that is an error. The message say the error messages say that the module hosting is private. In other words, we have the correct paths for the hosting module and the add to waitlist function, but Rust won't let us use them because it doesn't have access to the private sections. In Rust, all items, functions, methods, structs, enums, modules, and constants are private to parent modules by default. If you want to make an item, like a function or struct private, you should put it in a module. Items in a parent module can't use the private items inside child modules, but items in a child module can use the items in their ancestor modules. This is because child modules wrap and hide their implementation details. Child modules can see the context in which they're defined. Continue with our metaphor. Think of the privacy rules as being like the back office of a restaurant. What goes on in there is private to restaurant customers, but office managers can see and do everything in the restaurant they operate. Rust chooses to have the module system function this way so that hiding inner implementation details is the default. That way, you know which parts of the inner code you can change without breaking the outer code. However, Rust does give you the option to expose inner parts of the child. I don't think you should be exposing the inner parts of any child. Modules. Code to outer ancestor modules by using the pub keyword to make an item public. Exposing paths with the pub keyword. I feel so bad for this kid. He plays Rust too much. He came in, he was expecting some Rust, he did not get any Rust. Poor guy. Let's return. Look, you will learn Rust. You will learn Rust. It's not consensual. We will teach you it. Let's return to the error in listing 4.7 that told us of the hosting module. That told us the hosting module is private. We want the eat at restaurant function in the parent module to have access to the add to waitlist function in the child module. So we mark the hosting module with the pub keyword, as shown in listing 7-5. Right, so we just want to public the hosting module. Alright. Unfortunately, code in listing 7.5 still results in an error, as shown in listing 5.6. What is the error? Oh, because this is right partial file? No, why would I ever want to do that? Because this function is not public. Probably want that to be public. Compiling restaurant add to waitlist is a private function. This is just trying to pound into our heads that unless you state it's public, it's private. What happened? Adding the pub keyword in front of the mod hosting makes the public module public. This change, if we can access front of house, we can access hosting, but the contents of hosting are still private. Making the module public does not make its contents public. The pub keyword on a module only lets code in its ancestor modules refer to it, not access its inner code. Because modules are containers, there's not much we can do by only marking the module public. We need to go further and choose to make one or more of the items within the module public as well. Okay, makes sense. See, that table is still private. I really like that. Again, private by default, and just adding pub to one thing won't make the entire thing public. It allows us to have... I like that. That's good. Let's also make the add to waitlist function public by adding the pub keyword before its definition, as in listing 7-7. Mod front of house. Mod pub. Sorry. Yep. Yeah, it's just telling us to do what I did. Now the code will compile. You see why adding the pub keyword lets us use these paths in add to waitlist with respect to the privacy rules. Let's look at the absolute path and the relative paths. In the absolute path, we start with crate, the root of our crates module tree. The front of house module is defined in the crate root. So in the same place, see that restaurant. These two things are siblings. Well, front of house is in public because the eat at restaurant function is defined in the same module as front of house. That is, eat at restaurant and front of house are siblings. We can refer to front of house from eat at restaurant. Next is the hosting module marked with pub. We can access the parent module of hosting, so we can access hosting. Finally, the add to waitlist function is marked with pub, and we can access its parent module. So this function all works. Alright, I think that's fairly understandable. From top down, we must make every single thing that we want to publicly use outside of its context public. So, add to waitlist can use CDAT table, and CDAT table can use add to waitlist, but hosting cannot use anything outside of hosting cannot use either of these unless we make it public. So mod serving is allowed to use hosting perfectly fine, but it's not allowed to use CDAT table, because CDAT table is not public. Makes sense? In these relative paths, the logic is the same as the absolute paths, except for the first step. Rather than starting from the crate root, the path starts from front of house. The front of house module is defined within the same module as eat at restaurant. The relative path starts from the module in which eat at restaurant is defined works. Then, because hosting and add to waitlist are marked with pub, the rest of the path works, and this function call is valid. If you plan on sharing your library crate so other projects can use your code, your public API, your contract with users of your crate, that determines how they can interact with your code. There are many considerations around managing changes to your public API to make it easier for people to depend on your crates. These considerations are out of the scope of this book. If you're interested, however, read these guidelines. If you want to publish something, read all of this. Probably read it more than once. Or don't, and just throw things into the aether. Somebody else will fix it. It's open source, right? Best practices for packages with a binary and a library. We mentioned a package that can contain both binary crate root as well as a library crate root. And both crates will have the package name by default. Typically, these packages with the same pattern of containing both a library and a binary crate will have just enough code in the binary crate to start an executable calls code within the library crate. This lets other projects benefit from most functionality that the package provides. Because the library crate's code can be shared. The module tree should be defined in source/lib.rs. Then, any public items can be used in the binary crate by starting paths with the same name of the package. The binary crate becomes a user of the library crate, just like a completely external crate can use the library crate. You can only use the public API. This helps you design a good API. Not only are you the author, but you're also a client. Alright, that makes sense. In Chapter 12, we'll demonstrate this organizational practice with a command line program that will contain both a binary crate and a library crate. I got a sneak peek of Chapter 12. I'm very excited for it. We are creating something called grep. Looks very fun. We have a quiz here. What is the keyword you use at the start of an absolute path to an item in the current crate? That'd be a crate. An absolute, yep, crate. Determine whether the program will pass the compiler. If it passes, write the expected output of the program as if it were executed. We have a public module named foo, a module A, which is private. a module bar, which is private, public function B. Foo, public, bar, not public, does not compile, cannot use bar. Determine whether it passes. We have public mod foo, public mod bar, public function B, and public function A. We are running A. A is a public function, part of foo. This is fine. We can do this. We can check A, which simply uses bar, which is a sibling, but it is public. So either way, it would have been fine even if that wasn't public. And it runs the public function B. I think that does compile and prints B. Don't see why it won't. We got 3 of 3 correct. For example, an absolute path to item B and module A would be crate A, B. Okay, this does not compile. B is not accessible to main because the module bar is not marked as pub. Thirdly, it does compile and outputs B. It is valid within foo to use relative paths to refer to items within bar. Okay, starting with relative paths, starting relative paths with super. I'm guessing that's 1 up. So we have A, B, C, and we use super within C. That would be B. Let's see if I am correct. We can construct relative paths that begin in the parent module, rather than the current module or the crate root by using super. So this is the dot dot syntax. Start of the path. This is like starting a file system path with the dot dot syntax. Using super allows us to reference an item that we know is in the parent module, which can make rearranging the module tree easier when the module is closely related to the parent. The parent might be moved elsewhere in the module tree someday. Consider the code in listing 7-8. Oh, so what this is saying is that we might have like animals, marsupials, ape, which can take information from marsupials. Ape isn't a marsupial, but who cares? And we can move marsupial anywhere we want, and ape can still get stuff from marsupial. Why did I think marsupial? That's like rats and stuff in Australia. Consider the code in listing 7-8. That models the situation in which the chef fixes an incorrect order, personally brings it out to the customer. The function, fix incorrect order, defined in the back of house module, calls a function deliver order, defined in the parent module by specifying the path to deliver order starting with super. We have a function, deliver order, we have a module, back of house, function, fix incorrect order, where it cooks the order, super delivers order. So it goes up from fix incorrect order to back of house, and calls cook order. The fix incorrect order function is in the back of house module, so we can use super to go to the parent module of back of house, which in this case is crate the root. Oh, that's crate. That's crate? Yes, of course this is. Of course this is, because back of house is in. Yeah, okay. Okay, yeah. I don't know why I thought that was another piece of module. I'm tired. From there, we look at deliver order and find it. Success! We think the back of house module, the deliver order function, are likely to stay in the same relationship to each other and get moved together should we decide to reorganize the crate's module tree. Therefore, we use super, so we'll have fewer places to update code in the future as code gets moved to a different module. Making structs and enums public. We can also use pub to designate structs and enums as public. But there are a few details extra to the usage of pub with structs and enums. If we use pub before a struct definition, we make the struct public. The struct's fields will still be private. Okay? We can make each field public or not on a case-by-case basis. In listing 7-9, we defined a public backpass breakfast struct with a public toast field, private seasonal fruit field. This module, this models the case in a restaurant where the customer can pick the type of bread that comes with the meal. The chef decides which fruit accompanies the meal based on what's in season and in stock. The available fruit changes quickly, so customers can't choose the fruit or even see which fruit they'll get. Alright, so we have back of house, public struct breakfast with a public toast string, a seasonal fruit string, implementation of breakfast, public function summer, which takes in toast, outputs breakfast, outputs a breakfast struct with toast, string from toast, seasonal fruit, string from peaches. Okay. We have public function eat at restaurant, order a breakfast in the summer with rye toast, let mutable meal, back of the house, breakfast, summer, rye. Change our minds about what bread we'd like. Meal.toast equals string from wheat. I'd like wheat toast, please. Next line will compile if we uncomment it. We're not allowed. See or modify the seasonal fruit that comes with the meal. Meal.seasonal fruit, string from blueberries. Not allowed. Can't do that. Because the toast field in the back of house breakfast struct is public, in eat at restaurant, we can write and read to the toast field using dot notation. Notice we can't use the seasonal fruit field in eat at restaurant, because seasonal fruit is private. Try uncommenting the line and modifying seasonal fruit field. You see what error you'll get. That's a good question. Let's just straight out copy this. Let's comment this out. Let's paste this in. I see no reason with that go. That's fine. CR. What? What is the cargo? There used to be a thing. I'm fairly certain there's a thing that allows us to run and, see this, right? I thought it was cargo run. Who cares? Is it not cargo run? I really thought it was cargo run. A binary target must be available for cargo run. Oh, because this is a library. I see. This is a library. This is a library, so we actually haven't said anything should run. That's why it's not working. I see. Alright, there's an issue. That's not. Let's try cargo building. Fruit breakfast is private. Private field. Seasonal fruit is private. We have not compiled restaurant due to one previous error. Field, seasonal fruit struct breakfast is private. Here is the private field. Because the toast field in the back of house breakfast struct is private in eat at restaurant, we can write and read to the toast field using dot notation. Yep, that's what we just read. Also, note that because back of house breakfast has a private field, the struct needs to provide a public associated function that constructs an instance of breakfast. We'll name it summer here. If breakfast didn't have such a function, we couldn't create an instance of breakfast in eat at restaurant, because we couldn't set the value of the private seasonal fruit field in that restaurant. In contrast, we have a public enum. If we make an enum public, all of its variants are then public. We only need the pub before enum key listing. For the enum keyword, as shown in listing 710. Okay, so an enumeration can in fact so all sections of an enum will be public if the enum is public. That does make sense. Because we made the appetizer enum public, we can use the soup and salad variants to eat at restaurant. Enums aren't very useful unless their variants are public, so it would be annoying to have to annotate all enum variants with pub in every case. The default for enum variants is to be public, Structs are often useful without their fields being public. So struct fields follow the general rule, everything being private by default unless annotated by pub. Good. There's one more situation involving pub that we haven't covered, and that is our last module system feature, the use keyword. We'll cover use by itself first, and then we'll show how to combine pub and use. Alright, it looks like next we have a quiz. And then I think I'm probably going to end this. We're not too far off from the end. Starting a new one would be a bit meaningless. Determine whether the program will pass the compiler. Passes, write the expected output of the program as if it were executed. We have public mod A, public mod B, public function F, public mod C, public mod F, public function, so on and so forth. Public, main, create, A, entry. So we have A. And we have entry, which is a public function, which uses super. Okay, this is kind of, thank you for that. We have a super, goes up to create. We have B. It's all public. Of course, it's going to be fine. We have a public C, and then we have a public F. At which point we print line C2. Does compile, output C2. Determine whether the program passes the compiler. If it passes, write the expected output. Alright, so we have public mod point, drive debug, public struct, point. 2 points of I32, which are private. Implementation of point, public function origin. Takes in and returns self point 0, 0. Function main. Let mutable p equal point. We have access point. We have access origin. We have access. Yes. P will equal 0.00 because this is within the same, these two things are siblings, so it can access the fields of this, I believe. I don't see why not. P.0 plus equals 1. No, you can't do that. Does not compile. Does not have access to these because they are not public. This is a struct, even though it's a tuple struct. Not public. Does not compile. Got these correct. Context. Entry uses the path, yep, is within the module A. So super refers to a parent of module A, which is the root crate, then the child of B. The child B of the root is the outermost module B, whose child C contains a function F that prints C2. Secondarily, while the point structure and the origin static method are both public, the field I32 is not marked as public. Therefore, directly accessing P.0 outside the point module is not allowed. This program would compile if line 3 were changed to pub struct point pub I32, pub I32. This is good. I love getters and setters because I love putting logic which ensures that a change is correct within the function itself. So that's good that this is the thing. Usually, so what would be here likely would be an implement point setter, which you would pass in what you want to change the I32 to, and then it would change it within the correct, within a place that has access to point in the same way as it did when it sent it. Good stuff. Alright, well, thank you guys for being here, but I think that this is it. We're going to continue next week with the last two of these, perhaps get into common collections. This should be a quite easy and quick one. But I believe that is all for today. Thank you again for being here, Banat. I'll talk to you later about the project we're building. Goodbye. Wish you all the best.